In this lesson, we're going to be talking about the arithmetic of functions. So we just got done with a lot of lessons involving transformation of functions. So those are changes that we make to the graph. Here we are talking about changes that we make to the function, and more importantly, how they interact with other functions. So arithmetic, if you just think of arithmetic itself, you think of the simple math that you learned when you were, in elementary school. So we're going to be doing those same operations only with the functions. So there are 5 operations that you're going to be expected to do in this quiz with 2 given functions: addition, subtraction, multiplication, division, and what is called function composition. Function composition is when we plug the rule of one function into the other function in place of the variable. So the first 4, of course, everyone knows what they are. But function composition, sometimes people have not heard of. You did study it in Algebra 1, but there's your definition in case you've forgotten now. Most of them just have one format that you're going to see the problems written, but multiplication and composition both have 2, so I want to make sure you recognize both of them. If they want you to do multiplication, sometimes they'll give you this big filled in circle that's in the middle, and sometimes they'll give you the little tiny multiplication dot. So both of these mean to multiply. With function composition, there's the nested notation, and we read this f of g of x. So there's nested like that, where you have one function inside the parentheses of the other. And then there's this other notation where we have an open circle in the middle of them. So the big thing is, please do not think that this is multiplication, because this guy right here, the open circle, not the same as these 2 over here. The other mistake that I see students make a lot is just from not understanding the notation. This x here is just like the f of x in a regular function. This is saying f plus g of x. What I get sometimes is students who think that this means they then have to multiply by an x. This is not multiplication. So we are not multiplying by x at the end. So don't make that mistake and try to do that. This is just the notation. If you see this, all you're doing is adding the 2 functions. So here in example 1, our first function is x cubed, and our second function is negative x plus 4, and it's asking us to perform these operations, this arithmetic, on these functions. So f plus g of x just means that we're going to take f of x and we're going to add it to g of x. So f of x plus g of x. Now when we add, things get to keep their signs. So this gets to stay negative and this gets to stay positive. So I have x cubed minus x plus 4. Now, none of these are like terms, so we would say that this is f plus g of x. And that would be our final answer. Generally, remember that when we have functions, we usually go from the highest exponent down to the constant last. All right, f minus g of x. So this one, we're going to have x cubed minus the negative x plus 4. With subtraction, remember what happens is we change all the signs in the second function. So we're distributing this negative. So that gives us, for f minus g of x, we have x cubed, minus minus becomes a plus, so plus x, negative plus becomes a minus, minus 4. And again, none of those are like terms. We can't combine them, so that's our final answer. C, filled in circle here means that we are supposed to do multiplication. So f of x times g of x is what it's asking us to do. So again here, because this is a monomial, that means that we're going to distribute. So f times g of x equals, so my coefficient here is a 1, here it's negative 1. 1 times negative 1 is negative 1, so I know it's going to be negative. X cubed times x, which really, remember, is x to the first, is x to the fourth, because we add the exponents when we multiply. Then x cubed times 4 gives me 4x cubed. None of these are like terms either, so leave it as is, and that is our answer. Last one for example 1. This is an open circle, so that means this is composition. If you are more comfortable writing it the other way, remember this is the same as this guy. And what it means is we plug the rule of the inside function. We always start with the inside function into the other function, the outside one, in place of the variable. So the first thing I always do is I just start, just like PEMDAS, with inside the parentheses, and I'm going to put what the rule for g of x is inside that parenthesis. So g of x is negative x plus 4. And so now what we have is f of negative x plus 4. And what that means is that we're going to plug negative x plus 4 in place of the variable in the f of x function. So I go to the f of x function, and in place of its x right here, I'm going to put negative x plus 4, and then the rest of the function set to cube it. Now, they're not going to make you multiply that out, so this would be perfectly acceptable to leave your answer. So we put the rule for g of x in place of the variable in f of x's function. All right, example 2, same thing, but different functions here. So A, we've got the little multiplication dot, so this is to multiply. So we've got 2x squared plus 1 multiplied times negative 3x minus 5. Now, unlike in example 1, these are both binomials. So that means that we're going to need to FOIL here. So f for firsts, 2 times negative 3 is negative 6. X squared times x is x cubed. Outsides, 2 times negative 5 is negative 10, and x squared. Insides, 1 times negative 3x is negative 3x. And then last, 1 times negative 5 is negative 5. We would then look to see if we had any like terms. If they were both linear, we would have like terms, but in this case, we don't, because we had one that was quadratic and one that was linear. So none of these are like terms, so this would be our answer for f times g of x. B, f divided by g of x. So f of x divided by g of x. Now, here's the thing that's important about division, and I'll go ahead and write this up at the top here. Anytime you have division of functions, we need a domain restriction. All of them. So if you see a division problem and an answer does not have a domain restriction, then it's not the right choice. For what makes the denominator 0, because remember, you're not allowed to have 0 in the denominator of a fraction. So in this case, we can't simplify this fraction anymore. However, we need that restriction. So what we do is we take the denominator and we set it equal to 0. So we'd add 5, which gives us negative 3x equals 5. Then we divide by negative 3, and that gives us negative 5/3. And so what we have to write is x not equal to negative 5/3. This is my domain restriction because that is the value that would turn my denominator into 0. Because if I plug in negative 5/3 for x, that gives me 5 minus 5, which is 0. So again, anytime you have functions in the denominator, so it's not just a number, you've got variables and whatnot. So that means you're going to need this. So if you have a division problem and the denominator has a variable, do not choose an answer choice that is missing a domain restriction because it's not the right one. Okay, this one we have g divided by f of x. So still division, but in the opposite order. So that means g of x divided by f of x. And again, I can't simplify anything in this division problem, but I need to figure out if there's a domain restriction here. So subtract the 1, divide by 2, and then I would square root. Now this one technically would give an imaginary answer, so this isn't really the best example that I made up, but we're just going to pretend because you would do the same thing. Typically, we would probably have a minus here. So x can't equal plus or minus the square root of negative 1/2, and that would be our restriction. All right, last one, we have g of f of x. This is function composition. So again, I start with whatever the inside function is. Remember that on this notation, the inside function is the second one. So I had rewritten it up here to illustrate that. So I'm going to do g of 2x squared plus 1. So what that means is I'm going to plug 2x plus 1, or 2x squared plus 1, into g of x in place of the variable. Everything else about this equation stays the same. So g of f of x is going to equal negative 3 times, it was x, which was the variable, so I'm going to plug 2x squared plus 1 in instead. And then I have my minus 5 that was in the original problem. Now this one I would simplify because I need to distribute here. So negative 6x squared minus 3 and then minus 5, which gives us a final answer for g of f of x as negative 6x squared minus 8. And so that would be our final answer. So again, you've got 5 different operations to consider, and make sure you reach out if you have questions.